Hi, thanks for inviting me. So I'm Scott, and I'm here to present on deploying a multi-cloud MMORPG with Terraform, Nomad, and Consul. So for those of you who may not be aware of what an MMORPG is, it's a massively multiplayer online role-playing game. So you can play with your friends online together. You can kill monsters, collect loot, and the point is it's a shared experience, a shared world, and it's a persistent world too. So even if you log off, you can log back in. This particular game was created by Mozilla to showcase some of the new features of HTML5. It was written in JavaScript and uses Node.js on the back end. And for the multiplayer networking capability, it uses WebSockets for real-time data transfer. And it's just a really fun game if you never had the opportunity to play it. It's a great way to waste an afternoon. The reason why I chose this was partly on the play of words of MMORPG and multi-cloud, which is really what I wanted to talk about, was how do you approach the multi-cloud? How do you how do you architect for that? And more importantly, for the infrastructure, how do you design for something like a container orchestration platform that uses multiple clouds to deploy a service? So what I'm using here is commonly known as the HashiStack, although I'm not actually using Vault in this particular case. It just wasn't really necessary for the kind of the proof of concept that I was trying to get across. So as a reminder, if you're not familiar with the HashiStack, it's kind of like the all it together is better. And so I have Nomad, that is my application scheduler that can run Docker containers, which is actually how my MMORPG is. It's just an application that runs as a Docker container and is scheduled by Nomad. It's networked together with Consul for service-to-service discovery, and then it's deployed using Terraform. And this is where the multi-cloud aspect comes in, because actually I have some containers that are running on AWS, some containers that are running on Azure, and so I'm able to schedule jobs on either one cloud or the other and have it be meaningful and impactful. So why multi-cloud? This is actually a question that comes up a lot because most people only think of the pros, because there actually is a lot of good things about why you might choose the multi-cloud over single cloud or running in your own private data center or something like that. So the principal pro, I would say, is flexibility. You have the ability to choose the kinds of services that you want, the kind of cloud that works best for yourself, and possibly you can leverage this flexibility for cost savings. If you are familiar with AWS, you might be able to pick spot instances or the equivalent on Google Cloud or Azure. And again, this flexibility could prevent you from being locked into a particular cloud vendor. You know that you are what services you want to use, and if the cloud is not giving you the cost savings or the benefits or the attention that you want, you can just switch over to another cloud vendor. And then there's the resilience aspect of it too, because if one cloud were to go down or an entire region were to go down, then you would still have the backup to be able to switch over or fail over to another cloud. For example, Netflix could have avoided they could have avoided their outage had they gone with a multi-cloud strategy. And then furthermore, it could just be compliance. You could be required to use multi-cloud, especially if you want to deploy your application into particular regions. For example, if you want to deploy into China, you may be required to use the Alibaba cloud because those run in the data centers located in China. So again, why multi-cloud? Well, there's a lot of pros. There's a lot of good things to like about multi-cloud, but people forget what the cons of multi-cloud are, which are architectural and operational complexity. Principally, it takes a lot of work to design a system that uses the multi-cloud, especially effectively. and it takes it's hard to find people even that are qualified to be able to design such a system. It's hard enough to find people that are good with one cloud, let alone multiple clouds. Furthermore, you also have security concerns because now you have data being transferred between multiple networks. How do you manage all of that in a safe manner? So now that we mentioned the pros and cons, uh, I just want to mention that Terraform makes multi-cloud easy in theory. We have configuration files, we have Terraform providers, and each of these Terraform providers is responsible for making API calls to different clouds. So this might be AWS, this may be Azure, this may be Google Cloud, it may be other clouds, even your local machine. It doesn't really matter. It's just as hard as configuring a new provider and using the resources that provider defines. But again, the difficulty is not really with the Terraform, it's with how do you design a system that uses the multi-cloud effectively and that is not going to be overwhelming to operate on an ongoing basis. You don't want to be having to double your operations team size just because you decided to go with the multi-cloud. So who am I and why am I talking about MMORPGs or the multi-cloud? Well, I'm Scott Winkler, and I am a software developer at Ellie Mae. I also happen to be the author of Terraform in Action, which is a pretty good book. One person even said that it was the best book available about Terraform at the moment, which I take great pride in. And Terraform up and running, but you have a new contender. And also, I am very proud to be selected as a core contributor to HashiCorp open source software for 2020. And as mentioned, I am a ballroom dancer. So this is a picture of myself with my dance partner at a competition earlier this year. So architecture. How did I design this system? And let's see here. To do this, it has using Consul and Nomad, and I just created exactly the same setup in Azure as I did in AWS. And then I have a federation that occurs between the Consul cluster located in Azure, the Consul cluster located in AWS, and then similarly for Nomad, I have a federation that occurs between the Nomad cluster there and in AWS. And actually, the Nomad cluster federation occurs automatically as a result of the console. And also, I could extend this to support multiple clouds too. Here, I just have Azure and AWS. Could also have done Google Cloud, but the kind of the point is given across, I would say. So there are actually 3 pools of virtual machines that I use to design this. So you have the console servers themselves, and these are responsible for creating the registration of the service discovery and all that. And there has to be an odd number of them. So this could be like 3 or 5 or 7 in order to establish quorum for the Raft protocol. Similarly, for the Nomad servers, you have to have an odd number, and Nomad connects to Consul. And then also you have this large pool of Nomad clients, which is managed by Nomad, the servers for scheduling the jobs. Here is a more detailed architecture diagram of actually the virtual machines and the pools of servers. You can see that I have an AWS data center, I have an Azure data center, I could have other data centers, I could have a private data center, doesn't really matter. But you can see that I have 3 pools of servers, one for the console, one for Nomad, and then another for the Nomad clients. And again, the console servers have to elect a leader, the Nomad servers have to elect a leader, and then you just have a bunch of Nomad clients that are doing all the work. How does the federation actually take place? Well, I'm federating both Consul and Nomad. So the Consul federation happens first. I have a public IP address of one of the Consul servers in AWS, and I pass that over to the Consul leader in Azure. And then that's how the federation takes place. Now, that's actually not best practice. Best practice would be to use a private IP address instead of a public IP address, but that would have required creating a network tunnel between the AWS and Azure data centers. And I didn't want to do that for this particular scenario because that was just a little bit too complicated. This is actually a problem or scenario in my book, Terraform in Action, and I wanted it to be able to be deployed in a pretty reasonable length of time. Also, Nomad federation takes place again using the public IPs between the Nomad servers in AWS and the Nomad servers in Azure, and this actually takes place automatically as a result of the console being federated. Stage one. So what do I mean by stage one? Well, when I think of Terraform deployments, especially fairly complicated Terraform deployments, I typically divide them into stages where I have base infrastructure and then I have configuration or application infrastructure. And this is all Terraform. None of it's not Terraform, but it makes sense to separate it into separate workspaces because it relieves the responsibilities of trying to coordinate too many things together. So in the stage one deployment, that's where I deploy Consul, that's where I deploy Nomad, that's where I deploy my network and my security groups, everything that I need to run my clusters and bootstrap my clusters. So by the end of stage one, I'll have a healthy Nomad cluster, I'll have a healthy Consul cluster, and the federation will have taken place. And then stage two is actually going to be deploying that MMORPG that I mentioned before. But it could just as well be any other kind of application or any other kind of container or any other kind of workload. It doesn't really matter. It does matter that it comes second, though, because it has to be deployed on the existing infrastructure. Here is the code that actually deploys the base infrastructure. It's not quite this simple. I did remove some things. You can see the full code on my GitHub if you're interested, but this is the most important part, where I have a module AWS, I have a module Azure, and remember I just said I'm using the IP address to have this federation take place. Well, that's exactly what you can see here, is that I'm passing the public IP of the Consul servers from AWS over to Azure, and that federates my Consul servers, and then Nomad will follow suit. And if you're interested in learning more about how what these modules are actually doing or how they work, they are on the public module registry. They're also in my GitHub account, so you can just take a look at them. They're very interesting modules, I think, because they could be generalized to deploy any sort of cluster, not just Nomad. All it does is it creates auto-scaling groups for your servers and then uses some configuration code to bootstrap the clusters. And so you could just pass in different configuration code and, for example, have it start up a Vault cluster or Kubernetes or Istio or whatever it is you want to deploy. It's a very general pattern for kind of deploying clusters. And then also, because I did the same thing in AWS as in Azure, if you're interested in the multi-cloud, you can kind of compare the differences between the two. And what I came to realize, at least, is that the clouds are not as similar as people make them out to be. There actually are quite a few differences, and it's not one for one all the time, although at least the functionality could be the same. Here is me deploying the Terraform configuration. You can see that it adds 93 resources. It has a whole lot of outputs. I wasn't able to display all of the outputs, but there's quite a few of them. mainly like the console UI and the Nomad UI and Fabio, which I'll talk about later. But this is just helpful so you don't have to dig through the state file to find this kind of information. After it's been deployed, I always like to check that console has started up successfully. And here you can see that the federation has taken place between the AWS data center and the Azure data center. So that's a good start. And also you can see that Nomad has started up successfully and registered itself, both Nomad and the Nomad clients. Because remember, there's the two pools. There's the Nomad servers and the Nomad clients, and they're both passing health checks and registered themselves with console. If I was to check the Azure data center, I would see the same thing. Then I can check Nomad, make sure that Nomad has started up successfully, and indeed here it has. You can see this is the Azure data center that I'm looking at. These are the 3 Nomad clients that are running. They don't currently have any workloads that are running on them, and this Nomad cluster has been federated with the AWS data center as a result of the federation. So stage 2. This is, as a reminder, I've already deployed the base infrastructure, and so now I'm ready to deploy the application on top of this. This is going to be the MMORPG that we talked about. And this is actually another picture of it just to remind you of the end goal is that we're going to have this MMORPG, and it's you can play with your friends, and it's a lot of fun. Here is the architecture for the application layer. Remember, this is a separate Terraform workspace. It's deployed after the base infrastructure has been deployed. And this is responsible for basically starting up 2 containers on 2 different clouds. One is going to be the web application, which is it is the UI for the MMORPG. And that's going to be responsible for serving traffic over port 80, or actually 999, but it's just HTTP traffic to the client. And so if a user was coming from the internet, they would hit the load balancer. They would be randomly assigned to one of the Nomad clients, which is why I have Fabio. It's an application load balancer that runs on all of the Nomad clients. So if I was given the wrong client, then it would redirect me to the right one that's running my web application. And then my web application needs to talk to my database in order to persist data, which it does by also going through the load balancer and over to AWS Azure. So this is kind of like the network traffic and how it actually works. And also you can get an idea of what I'm going to be deploying. I'm going to be deploying Fabio. I'm going to be deploying that onto Azure and AWS, all the clients there. And then also I'm going to have a MongoDB and a web app Docker container that's also going to be running. And really, those are the 2 important ones. Everything else is ancillary. Here is the configuration code that deploys my application. I have 2 provider nomads, each configured with a different address. This isn't strictly necessary. Well, it is necessary, but it's just due to an idiosyncrasy with how the Nomad provider was declared. I guess they didn't intend for you to be deploying multi-cloud workloads using the same Terraform with the same Nomad provider, but we do it here, so it's not too challenging, and we just have to pass in the different provider configurations. And this module MMORPG that I have created, which again is published on my public GitHub, and it's also found in my book, you can see that I just have to configure it with a couple things. These are just the external load balancers to be able that were deployed as part of the base application, stage 1. That is the load balancer IP address so that you can connect to the Nomad clients. When I deploy this, I get 4 resources that were added, and these are just my Nomad jobs that have been deployed, and I get an output for the BrowserQuest address, which you can see there is, and when I check in console, I can see that my Nomad job workload has been applied and has registered itself with console. I can see my Fabio, my application load balancer, that it's also registered itself with Fabio. So that's important because I'm only running one instance of the container, and I need to be able to route to the instance that's running that correct container. And then finally, if I go to this address in the browser, so this is the address of my external load balancer. See, it's the ELB, and it's running 9999. So this is the Fabio is doing this. And here is the startup screen, so I can create a new character. And if you were to give this address with somebody else, they could also create a character and you could play together. Just as a side note, it says PhaserQuest rather than BrowserQuest because I'm actually using a derivative that somebody created for using the Phaser engine, but it's exactly the same game as BrowserQuest. As a kind of supplementary thing I thought was interesting was I thought this game is a lot of fun, but it seems awfully hard to deploy it, and there's a lot of steps involved. And if you think about it, it's quite expensive too to be running just a couple of containers and the two different clouds. Why would I want to do that? Well, there's a good reason why you want to have Nomad running in two different clouds, because you make the clouds more similar. In fact, even the UI that you're using to access it with Nomad is exactly the same. So it doesn't, from a user perspective, they don't even know or care about what cloud they're deploying to. But again, it's also more expensive. You may have a minimum of, let's say, 12 instances or 9 instances per cloud, 3 for the Nomad servers, 3 for console, 3 for the Nomad clients. And so you double that, that's 18 instances that you're running to run 2 Docker containers. That's awfully expensive. So I thought, well, how else could you approach multi-cloud? Instead of using container orchestration platforms like Nomad, which are great in their own right, especially if you're running at scale, lots of workloads. But if you're just trying to run a simple application, it may not need all of that. So in that case, you might be better served by using managed services. So managed services are things like managed databases or IAM or IoT, or just anything where you're not worrying about the configuration on the virtual machines themselves, and very fundamental aspects of infrastructure components. And you can save a lot of time and money by doing this. Here is an example of how I redesigned the MMORPG to be able to use managed services, which is deployed using Terraform. And you can see that I'm still multi-cloud. I have resources in Azure and I have resources in AWS. I'm using Terraform to facilitate this. And again, I have my web application that's running and I have my database that's running. So if someone was to be able to access my game over the internet, they would go through the load balancer, which connects to a Fargate, which is running my serverless web application. And then that web application persists data by connecting to the database over the internet, which of course is probably not ideal, but it's just showing how you might have resources in 2 different clouds and connecting them together. Here is the code that will actually deploy this. It uses the module AWS, module Azure, and the module AWS just uses Fargate to be able to deploy a container. This could actually be used to deploy any kind of container. I'm using my image, I'm using my port, and then I'm using a command to be able to connect to the Azure database using this connection string, which is an output of the Azure module. And then there's an output here for the BrowserQuest address. This is all my public GitHub if you want to look at this. In fact, this is pretty much all of the code except the provider declarations. And I don't need to do a 2-stage deployment because I'm just using a bunch of serverless infrastructure and deploying my application directly with that. So here's me deploying that. I have the 37 resources that are added. So I have my database that's been created on Azure. I have my application that's been created. And then I have the BrowserQuest address. So now I can just directly play the game. And here I am with my friend. We're playing BrowserQuest, killing some rats, getting some EXP, collecting some loot. So if you want to play this game, I would actually recommend this approach. It's definitely a lot easier than trying to start up all of the Nomad and Consul. But also, it's worth looking into it if you are trying to run, if you're interested in Consul and running, or Nomad and running that at scale, especially in the multi-cloud. As an overview of what was covered today, we used Terraform, Consul, and Nomad, not Vault, sorry. Talking about why multi-cloud, the pros and cons of multi-cloud, and just why it's of interest of right now. And then for the first example, we used a two-stage deployment to deploy Nomad and Consul and deploy that with Terraform and federate them together, and then be able to deploy the application layer on top of that. The federation was done using the public IP addresses of Consul, and I just had to make sure that the two clouds could talk to each other. That kind of goes with the architectural complexity. I mean, if you're dealing with the multi-cloud, you have to be really aware of the differences between the two clouds, and sometimes this can be quite a bit of work. This particular scenario took me a better part of a month to put together. This can be simplified if you want to use managed services. So there's really two different ways to approach the multi-cloud. You can either think, how can I make the clouds more similar? Or how can I embrace the differences between the clouds and really take advantage of something? So for example, if one of the clouds has a really good machine learning tool that you would like to use, then that would be a good reason to go multi-cloud using managed services, because you can say, I'm going to use my primary cloud for everything, except I'm going to use this other cloud just for this one service that I like to use. And it's not too difficult to coordinate that, especially with Terraform. So just as a final thing, this is a shameless self-promotion. I am the author of Terraform in Action, and you can save 50% on my book with the code TS Terraform. And this you can find on the Manning Publications website, manning.com/book/Terraform in Action. And this whole talk that I went through today, and actually a bit more that I wasn't able to fit into the talk, is all found in my book, along with many other advanced use cases of Terraform. Chapter 10 is going to be released in the next few days, and pretty excited about that. My Twitter is Scott J. Winkler, and my GitHub, where you can find all of these code snippets and more, is Scott Winkler.